What is differentiation? Before you do the differentiation, you need to ask the question, is this thing differentiable? And what is differentiability? A function f from domain R to codomain R is differentiable at a particular point xa. To make it precise, I should say A is in R, is in domain F. I'm saying that this function f is differentiable at A, and I write this f prime A. Here's the notation. Few hundred years ago, Newton write this, and then somebody write this, somebody write this, somebody write this, somebody write this. These are all differentiation symbols. So what the heck is this? This means differentiation of f at xa is saying that limit x goes to a. If this is true, then you can differentiate it. Example, f is equal to x squared, then this guy is 2 at 1. So you just do this. This is fx. So fx is x squared. This is a. What's our a? 1. So 1, 1, 1. What's our limit here? Limit here is 2, which is what we want in the end, so it should be in the end. So there's no 2 here. Then what? Just simplify this limit. How do you evaluate this thing? This thing, I split it into this and then cancel out. Why I can cancel it? Because I'm talking about limit. I'm not talking about two functions equal to each other. Okay? So I can chop their head. Now I chop their head. Then I have this. I can limit this guy and limit this guy. Limit this. This is what? This is not a 1. This is a constant function. So therefore the limit is 1. Okay? And then limit this. I just put the x value inside is 1. So 1 plus 1, 2. That's it. This is the first way you can write differentiation, but you can have a second way, H notation. I have a particular number A, this part and this part are the same, nothing changed. Previously, I write x go to A. This is now changed. I no longer write x go to A. I write h go to 0. My x minus A is h. This is what? This is a gap between x and A, right? Now I'm saying this go to here is the same as the gap go to 0. But let me give you a new one. Okay. So suppose I have a function f. I call it f differentiable, and now I have letter q. Q stands for quantum. Wow, what the heck? I have a limit that is differentiation, but now I write a q below it. So now you have this. It's the same thing. Previously, the first one is x go to a. The second one is h go to 0. Now here's the third one. Q go to 1. If q go to 1, this thing have no gap. And the same thing, right? So that means what? That means who said that this is the only way you can define differentiation? This is the thing. Remember, sine function have 5 expressions. Nobody said that there must be a rule that this function only have one way to express it. Differentiation is a function. If sine have 5 ways to write it down, then differentiation also can have more than one way. Now I show you 3 ways. So this is new. Here is an example. Same thing. Differentiate this guy at 1. If I use this, it also gives me 2. How? Follow the expression. I have qx. What's my q? Q is just a constant q here, go to 1, so I put that how? What's fa? f1. A is 1, right? So, and then I just write down everything the same thing. What's f? F is q squared, because fx is x squared, so fq is q squared, so I have this. Then what? You have 1 plus 1, 2. Same. So for this notation, you also have differentiation. What about the h1? You also have 2. Of course. So x squared, differentiate of this guy at 1. So I write down the expression here, h go to 0. This is my f, right? So f whatever thing, I make it square. So this whatever thing is x plus h. So I have a x plus h square minus fx. So minus fx, and then I expand this. So x squared to xh minus x squared. So these two cancel out. That's give me this thing. And then h cancel h and no power, and h, that means I have this. And then what? Distribute. This is a constant function for h. X is variable, yeah, but for h it's a constant function, so that's why it's 2x. And then what? I can put this down here. I have this h go to 0, 0. So I have 2x. And then what? This is on whatever x. I can put x as 1, right? It give me 2. So therefore it's 2. The fourth way, for epsilon delta. So for all this guy, there exists delta. Okay, this big chunk of thing. I have an x near my a. How near? Delta near. Implies this is true. This is the expression next to my limit. This is the limit. They are near. How near? This near. Example. So I need to write this sentence and then simplify this big chunk of thing. Give you this. So this one cancel out. You can chop people's head. Okay. Now you get this and then you get this. So that means what? for any epsilon you give me, I just need to prove there exists a delta such that this is true, then done. I will just take the same guy. So that means you give me the gap 0.5, okay, then my delta is 0.5. You give me the gap 1000, then my delta is 1000. Then this is true. Done. So that means what? This part is also content last week. Nothing new. The only thing new is that now this thing, which is a function, I call it big F, define something, I call it differentiation. So later, if I write a big bracket, I don't care about what's inside, I can call it another function. I is a what? A limit. It defines something called integration.